We are from group number 3 to DMF1/1. We are going to discuss about truss, question number 6-19, and this is our question.
First, we draw a free body diagram. The free body diagram is to find the distance between joint EDC. First, we state that the distance between joint C and D as B, joint D and E is D. Then joint CE is C. After that, we assume that joint BD as A and the angle at BCD as theta. We have to find out theta, so we using trigonometry function to find out theta. After to find out the theta, then find A, B, D by using trigonometry function also. And D, we just using C minus B. Then we will get the distance of D. Next, we draw a new free body diagram. This is because we need to find the mass of each joint. We will result that at each joint have multiple mass. We have to sum up all the mass at the same joint and multiple with the gravitational force 9.81 become the external load at each joint. After sum up all the mass at each joint, we will get 5 external load, which the external load at A, at joint B, joint C, joint D, and joint E.
To draw the free body diagram at each point, we have to assume all of the arrow are compression because according to question, it says that force applied at each member. For joint C, we take 259 Newton, which we get from above is the weight acting on the joint C, and FBC and FDC. The trigger is the distance from point D to point C. For summation of Fx equals to 0, we take all the force that exert on x-axis, which is FBC plus FDC times 3 over square root 13 equals to 0. And for summation of Fy, which force that exerts on y-axis, negative 259 plus FDC times 2 over square root 30 equals to 0. Solve and we will get 466.9 Newton compression. Insert the value of FDC on Fx equation and we will get 388.5 Newton tension because the answer is in negative. So the arrow are pointing out of the point C. For joint B, we take 340 Newton as the force acting on point B, FBA, FBD, and FBC. Do the summation of Fx equals to 0 and substitute the value of FBC, which is negative 388.5, and we will get FBA equals to 388.5 Newton tension because the value of FBA is negative. The arrow is pointing out of the point B. And for the summation of Fy equals to 0, we take negative 314 plus FBD and we will get FBD is equal to 340 Newton compression. For joint D, the force applied are FAD, FBC, FCD, FED, and external load 502 Newton. For summation of Fx equals to 0, we take FAD times 3 over square root 13 minus FCD times 3 over square root 13 plus FED times 3 over square root 13. Substitute the value of FCD, which is 466.9. The 3 over 13 can be factorized, so we just cancel it and we will get FAD plus FDE minus 466.9 equals to 0 for equation 1. The same goes to summation of Fy equals to 0. We take negative FDA times 2 over square root 13 minus FBD minus FCD times 2 over square root 13 minus 502 plus FED times 2 over square root 13. Substitute the value of FCD and FBD. Solve it, and what we left is minus FDA plus FDE equals to 1938 Newton for equation number 2. Since both equation has two unknown, we have to make a simultaneous equation. Substitute from equation number 1, FDA plus FDE minus 466.9 equals to 0. Let FDA equals to 466.9 minus FDE, we will get equation number 3. And then substitute equation number 3 to number 2, negative bracket 466.9 minus FDE close bracket plus FDE equals to 1938 Newton. Solve the equation and we will get FDE equals to 1202.5 Newton compression. And then from the equation number 3, we just have to substitute the value of FDE. FDA equals to 466.9 minus 1202.5. We will get FDA equals to 735.6 Newton tension because the value of FDA is actually negative. So the point of FDA will point out from the point D. So basically, this is how to do truss to find whether the point has tension or compression. And that's all from us, group 3. Thank you for watching.